All right. So we had the idea of next to add. So I'm going to keep this one over here. This is part of my add algorithm, but I want to put it off to the side. And I'm going to create a new variable. And I'm going to call it one before. So what we're going to do is we're going to play with the idea of insert or delete. Either one of them kind of works right here. So in an insert, what I might want to say is, okay, well, I don't remember exactly the order of everything in, right? And I actually forgot Jovial on my list here, right? I kind of skipped from well, actually 895, but let's just say I want to insert something here. So let's just say after Pascal, maybe before I learned data. Actually, I think I learned assembler before I learned data. I don't remember if that's true or not, but let's just say it is. So I want to add in assembler to my list. And I want to add this in, not at the end of the list, but I want to insert it before Ada after Pascal. So if I look at my list, the head starts here. So this is the 0th item on the list, because we start in zeros for the most part in computer science. 0, 1, 2, 3. So I'm going to add this in at the spot 3. So I want to move Ada down essentially, which is easy for me as a human to do. I can just, boop, there you go, just add it that spot. But how do I do it from a computer standpoint, from an algorithm? So I want to add this idea of the one before. So I don't want to I can't add this in at the next to add, because if I did that, I would say, okay, well, I want to start at 0, 1, 2, 3, and I'm pointing it next to add. And so I can't change my list at this point, right? Because I'm already at the place I want to put it. So if I put it right here, well, I end up not changing the list at all. I actually want to go to the one before. So here I say, okay, well, I want to go to the one before location 3. And so 0, 1, 2 is the place I want to go. So the same logic works. I start, okay, actually, I'm going to, in this case, probably check it. Hey, does this location make sense? If it's a negative location or if it's bigger than my list, I'm not going to do anything at all. But otherwise, I can actually probably just use a for loop here, right? So I can say, okay, well, I'm going to start here, and so I'm going to go 0 to the one before. So I'm going to put it at 3, so I'm going to go to 2. So 0, okay, there's the next one, 1, 2. All right, so this is the one before. So the one before variable, I want to point to the node before. Now, again, in an array, I just say jump to item 3 and change it. But now the bad news is I have to use this little extra pointer here. The good news is when I come to insert, I can just say, okay, well, Pascal is actually now going to point to assembler. But before I make Pascal point to assembler, what I'm going to say is the next one after assembler is going to be Ada. So I'm going to say this one's next is Ada, and then this one's next is assembler. And so by finding, move my list up here a little bit, by finding the one before, I can say, okay, well, assembler, excuse me, comes after Pascal, the new one I'm inserting. And then, so I don't lose the integrity of the rest of my list, I make sure that assembler's next is equal to the one before's next. Right? I don't know who the one before is. I don't know it's Pascal in this case. So one before dot next, assembler dot next is equal to one before dot next. And then one before dot next is equal to assembler. And so I'm doing that little swap right there, and I can kind of insert my value here. So the same concept of one before also helps us, not just on insert, but also helps us on delete. So now that I think about it, I definitely learned Ada before assembler. There's no doubt in my mind. Well, maybe some doubt, but I'm pretty sure. So you know what I need to do? I need to delete assembler and then insert it again after Ada to make sure that happens. So the same concept is true for this one before. So I want to delete value 0, 1, 2, 3, assembler, the place I just put it, right? So I say, okay, well, okay, is 3 in my list? So is 3 negative? No, it's not. Is 3 greater than the size of my list, or equal to the size of my list in this case? No, it's not. 0, 1, 2, 3, 4, 4 out of my list. So that means I'm going to do a for loop again. So I'm going to go 0 where it's less than the one I want to go to. So I'm going to say, okay, next one before is equal to head. Okay, so then I'm going to move it forward. One before is equal to one before dot next. one before is equal to one before next, and I get to Pascal, right? So I moved up here. So I'm now at one before. And so I say, okay, well, I need to delete it. So what I want to do is say, well, the one before dot next is equal to one before dot next dot next. So this one doesn't go away. It just gets pushed up. No, I mean, this one, it doesn't get deleted. I mean, I don't actually crumble it up and throw it away. I just move the other one into it. So this one kind of exists, but it just kind of exists not pointing to by anything. So probably what I'm going to do in my algorithm is I'm going to keep track of the one I'm going to delete. And then this is going to be the value I'm going to return, because that's typically what happens in the remove method. And so then I keep track of this as my own little value. Just say, I'm going to call it return me. So I create my own little variable, return me, and I point this to one before dot next dot next, right? And then I say, okay, well, one before dot next, excuse me. And then I say, okay, I'm going to keep return me off to the side. I drop my variable here. And then I'm going to adjust my list, and then I'm going to say, okay, well, return me dot value, and then that gets returned to the user. And then this one, eventually, if you're dealing in Java, it eventually gets garbage collected. If you're dealing in C, then you should delete it yourself. If you're dealing in Pascal, it also gets cleaned up automatically. So that's the idea of the linked list and removing from it. Then if I want to add it in, I can just go tacking on it at the end. All right, so this is the idea of how I manipulate pointers to build linked lists. This paper example hopefully gives you this tangible idea that this relates to a real world thing. But that's also something you need to translate into the virtual world. And a bridge to there is DS Visualizer. That's why I have DS Visualizer out there, so you can play with these manipulations a little bit. But if you're a tangible type person, build some paper, move it around, or use drawings on paper if you want to, and move it around, and hopefully this helps you. Now, there's one other twist that's optional here that I'm going to show you, but it's the idea of a tail and perhaps the notion of a doubly linked list as well. So we'll come back to that in just a second if you're interested.